Hey everyone, got the sun setting behind me, so it might be a bit shadowy, I don't know. Time for a new bit of test kit. This is exciting. And sorry guys, already cut the box open. But you know, when you get these things, you have to, check the shipping, check for damage, make sure she's all kosher. So, what have I got here? You've probably read the title. Here we have an MST-9001A ECU engine simulator, engine signal simulator. So cool. I'm quite looking forward to this. Hopefully it does the business. I get sent engine computers quite often, and while I do fix them, it'd be nice to be able to test it before shipping it back, and just to know for sure, give some peace of mind, you know, make sure it works. That's what this thing does. Let's have a nosy. Comes nicely air bubble wrapped. Interestingly, we have 2 copies of the user manual, very brief user manual. So I will say that there is no full-on instructions on how to for every computer type. You've got to have some prior knowledge on how ECUs work and what the signal levels to be expected and all that sort of thing. You have to be able to find pinouts for the connectors. So you're going to end up with a box like that out of a computer, and you're going to need to know how to find out what pin does what. So you can hook it up to this. So it doesn't come with any information. It comes with a little bit about crank and cam waveforms. It comes with some, the software comes with some sample waveforms, but you know, if you've got 2 camshafts each with their own signals as well, then you're going to have to create triggers for that. Now I'm really disappointed in these guys because there's no CD in the box. I was unable to. It's supposed to come with a CD with the software for editing the waveforms. I don't know why it wasn't included. I did actually check to see if Customs had opened it, and they said no. They could tell me it was X-rayed at China, and that was it. So it should have been in the box. I have not yet heard back from the seller on where to download the software. I was lucky enough to find a guy on YouTube who has one machine like this, and after enough comments he kindly uploaded the software to a virtual drive so people can download it. So that's really cool. I think his name's Mark Salazar, I think. Excuse me if that's wrong. He's got a how-to waveform video, and amongst the comments there's a link to download the software. So if you guys end up in the same boat, check his video out. In the bag we have a bunch of banana plugs, because that's how you attach to the machine. And we have the hookup wire. So it has crimped ends with little crimp terminals that you can slide over the ECU pins. Hopefully that'll work for a range of sizes. Oh no, look, some are big, some are smaller. Hey, that was cool. Well thought out there. Good on them. And we have, oh, here we go. Oh, it separates into bundles of, we've got big terminals. That bundle has really small terminals. So cool. We have 3 size of terminals. Excellent. Love that. Pop them aside. Now, I did just see a video from a guy called Matthias, and he said that he got some wires, some clip leads from China, and they were made of iron, not copper. So I'm curious as to these, if they're copper or whatever. Let's try a magnet test on the wire there. They're not magnetic. So let's hope they are quality copper wires. They are pre-tinned at the end, so I can't really tell what colour the wire is further in. But yeah, let's hope they're decent. Obviously you can't solder to aluminium, so there's a good sign there, I suppose. Now for the grand reveal. just had burger fuel. It always leaves me feeling quite, horrible. So, cheers guys. Wash it down with a bourbon. Alright. Ta-da! This is the little beauty in question. Now there's a couple of models of this. I went for this one, sort of in between. The bigger one is the MST-9001. It just basically has a lot more outputs, a lot more analog outputs for other signals and things. But I didn't want the MST-9000 because it doesn't do diesel injector signals, as far as I could tell. So I got this one that does diesel injectors and petrol injectors. So whatever is in there is loaded correctly. But it only has 4 analog channels, so you can do your, your water temp sensor, your airflow meter, map sensor, whatever. I don't think it will be hard in the future if I needed more signals to create my own 5-volt source and just add that into the system. It's only outputting to the ECU. ECU is still going to run. Obviously, if you didn't have a water temp signal, it might think it's cold and be running rich. But for the most part, I guess we're just testing that once it gets a crank signal, it does fire the injectors and fire the coils and such, just to prove it's working. So once you hook it all up, you can hook up the OBD data lines so that they terminate to this connector. So you can plug a scan tool directly in there and check things, maybe do live tests, things like that. You can watch the live data that the ECU is reporting from your sensor output. So that's cool. I'm going to have to do a bit of experimenting. I think, so we've got power for the main box. We've got ECU power, which is like your battery always on, connected, and your ignition switch out. So you flick that on for your key, and then we've got these K1, 2, and 3, which I think are, what has it got here? Negative trigger switch signal. I'm going to have to look into what they do. I thought they were a switched output, just an on-off, but yeah, that's it. You basically hook up what you need to, and away you go. It looks, I thought this was bent, but it's the sticker for the wording or the artwork there is not sitting perfectly flat, possibly because the holes punched weren't perfect, so that it doesn't really sit perfectly flat. But it is flat around the edges. It is stuck down, so it's not going to be peeling up at any stage, which is good. There's actually a bit more weight to it than I thought there might be. It's not real heavy, but there's a bit of something going on in there. I'm quite interested about what's inside, because it does, obviously it does square wave for your trigger cam, crank and cam signals. You can do square wave. You can also simulate reluctor, so it's more like a sine wave. And I'm curious to see how they're doing that. It's pretty straightforward, to be honest. But do I take it apart and avoid the warranty? Okay, I don't think I will take it apart right away. Let's just make sure it works first. If you're interested, this was over $1,000 worth. So let's not risk any warranty issues. Although I can't imagine I'd be able to send it back for as little as I paid to get it over here. Let's plug it in then. I did order the 220 volt model. It was the option of, there's 2 options, so maybe it's a bit weighty because they're running a transformer in there, so let's hope they sent the right one. There's nothing on the back to indicate the fact. We have a USB cable, nothing to say it's 220 volt. It's completely bare. So yeah, here we go. Of course they sent the wrong power cable, so supply your own. I wonder if the earth terminal is attached to the chassis. 3, 2, 1. Woohoo! Yay! That looks cool. You can see how they're addressing the displays on the segments there. They're not flickering. It's the camera shutter. So we should be able to adjust these outputs all the way up to 5 volt. Hey, it's got a bit of good control there, because that took a few seconds to come up. Let's just try that one there. Yeah, it's gradual. Clearly there's some, I guess, protection in there. They don't want it to exceed 5. Yeah, look at that. We can adjust the output to the ECU as well, which is kind of cool. So got 12 volts there. Whoa, 29 volts. So we can run 24 volt ECUs on this too, which is good. Good to know. Just don't bump that knob while you're busy doing a 12 volt ECU. 13.5 is suitable for those. This is our RPM. That's a endless, here we go, endless rotating. That's just a rotary encoder. Operating current, which is drawn from the ECU. Sweet. So anyway, let's knock all those down to half. And see, it does take a little while to come down as well. I'm sure over time I'll work out what's a good value to leave them on. So if we go ECU power switch on, so this is obviously, our light comes on here. We have power out to the ECU ignition switch, and that should probably start the, does that start the signal output? I mean, I have a signal loaded. I would have thought that might be calculating engine speed right off the bat. Who knows? Let's turn these K switches on. They don't do much. Yeah, cool, alright. Well, it works. Now we can take the lid off. I'm gonna two-part this video. And we're just gonna have a quick look now to see what they're all about. And then I'll do another one actually using it. Because there's no information out there on these pretty much. Like anyone that has got one, there's only like a couple of guys I've seen videos with. One guy, the guy that uploaded the software, Mark, he's been pretty good with his videos and what he shows the use of it, but it's not hugely in depth. And then there's another one that I've seen in action that I think was this model, but it's just seen in action. There's nothing talking about how to use it, so we'll give it a shot, right? There's a bunch of screws on each side, and I think that'll release the cover. It's a bit smaller than I depicted it to be. I'll give you an idea. It's 300 long by 190 by 160. Sometimes they put the dimensions of stuff like that in, but in this case didn't seem to be mentioned anywhere. I guess the good stuff will be right under the top, because we've got a front and back panel, so here we go. Whoa, look at that. Smells new. Interesting odor. While I was waiting for my camera battery to charge again, I thought I'd go ahead and terminate some of these leads. Now, I was having some trouble with getting the wire to stay under the screw there. It's not the fattest wire, of course, but anyway, little tip, get some pliers, just pinch the end of it there and fold it over to give you a bit of a loop, and then that loop gives a bit more bulk to sit down in the post so that the screw can clamp onto it. Now obviously you don't want to screw onto the insulation, so it's pretty bit hard to see, but the post is basically a hollow in there, hollow metal cylindrical shape with a screw on the side. The top edge of that cylinder, you want the insulation, you can feel the edge of the insulation sitting on the edge of that when you pop it in, so you don't want to obviously go all the way down the bottom, or you might accidentally screw the screw down on the insulation, but you can feel where that sort of sits pretty good. So you just get that down till it feels good, and wind it up, make sure it's tight, give it a bit of a tug, pop it on your meter probes for a quick test. Job done. So having a look, we've got a nice big switching power supply here. It has got a label on it and a switch in here that you switch for 110 or 220 volt. So you can check you got sent the right one. If you wanted to, before you plugged it in, you could check that switch is in the right position for your country. You can see some high powered resistors down the middle there. That's quite likely for simulating, maybe simulating coil loads, for example. Down here we have a switching regulator. I'm not sure, it could be a buck boost regulator, as we can vary from, well, how much voltage is coming out of this thing anyway? Does it actually say? It's got plus V. It doesn't actually say what the V is. Quite possibly something to do with that. On the top panel here we've got a processor there. We've got a 5 volt regulator. And we've got some other ICs. Not entirely sure. I guess one of them would be perhaps obviously stores the code in it, or the waveform code, and whatever operating code it needs, unless the micro has that on board, of course. The front panel there with all of our banana jacks, they are just attached via nuts screwed to the PCB. We've got some relays across here. One of the more interesting little arrangements I noticed. So what we have here is an inductor, and through the center of the inductor they've mounted a reed switch, and they've got quite a few of those across the back of the board there. I presume 1, 2, 3, 4, 5, 6. This will take 6 diesel injectors, 4 petrol injectors by the look of it. Maybe it piggybacks 4 of them, and there's 2 extras for the extra diesel ones, but I would say that's where your injector pulse goes through, which causes the reed switch to trigger, and maybe that's just being used to flash the LED. That was an interesting little design idea. From the other side there's a speaker, so that makes a little click each time one of the ignition fires, I guess. It gives you an audible sense of the engine running, which is kind of cool. That's the back of our rotary encoder, and we've got a crystal oscillator up here with some other chip. Oh, okay, so that's probably our little micro doing the waveform generation, being right behind the display for that. And then up the back there, I've just noticed we have what appears to be a current sense resistor. Nice big resistor there, because it does have ECU current on the display, and the overall construction is looking pretty tidy. So they've certainly thought about what they're doing by the look of it. And with it all back together, let's just double check it all still works. I'm sure it will. And on. There we go. Shall we take a quick look at the software then? So looking at the installation instructions, and it says to install this as the driver. So in trying to find the software, because this didn't come with it, I saw this and I thought, okay, well maybe if I search for this file it might point me at the actual software, but that's not entirely the case, because that particular file is just a USB to serial port driver. So for systems based on the chip that uses that, I guess, that particular UART. So that's promising, because the only thing I was concerned about is that there wouldn't be a driver for Windows 10, but I think we'll be okay. So I've installed the one that I found with the program, and there's a bunch of files. So now I guess what I need to do is plug it in and just see what it does. And the phone's going. So I forgot to push record after that phone call. where was I up to? Okay, driver installed. Yes. Now let's run the program. I've plugged it in, and I had to change the COM port. So you didn't see that, but it did say change COM port if it was greater than 9. So we go to port settings and just change it to a free COM port that is less than 9. Cool. Now plugged it in, it made a beep, and open the program. This is our program. I don't know, this is for the MST-12000, but that's what was included. So I'm presuming channel 1 is going to line up with channel 1 on this, because it's only got 4 channels of yeah, it's only got 4 channels. So looking at the bit of paper included, crank channel 1 and 2 is Hall type, channel 8 and 9 is magneto-electric. So the Hall type channel 1 and 2 is going to be our square wave, and channel 8 and 9 is going to be top and bottom of our sine wave. So all right, I got this far, and I'm not sure what this is. 240 Hace. Does it mention that in here? Oh, phase. It's supposed to say phase. So 240 degrees, or I suppose 72. In 36th pulse position, set phase is 72. Okay. I'm not sure how to scroll across to see past 46, or does that change if I make that 72? No. Oh, next page. There we go. Next page. Okay, so we can go all the way up to, oh, we can go for miles. I guess when you get to the end of your waveform, it must loop. So what I was going to do is go open, but it didn't, it hung. So let's exit. Then we'll go signal editing again. It keeps opening halfway across my 2 screens. And then we go open. It did not like these files, so we'll go up and do we have anything there? No, they were Excel files. We'll go here. These are ones that were kindly provided by Mark. So if we go, let's see what he's got here. He's got all sorts of things. He works on a bunch of different things, including vehicles, marine, all sorts of things. I'll pick that one. No, 54 plus 1. We'll do that one. Open. Yay! Okay, so there must be something funny. Maybe it's the naming, because it's in Chinese characters. Maybe it doesn't like the file names there. Let's do a test. Let's grab that one. Let's blitz out these characters. Oh, there's a 08 above that. They had no characters. Okay, and let's see if we can open one of those. Can I open? Wonder why. And then it freaks out. Then we have to exit the program. So we'll start again. Nope. And open. Might just have to create my own. Hey. Maybe it'd be interesting to put those into a text editor and just see what the difference is between those ones and these ones, for example. So here we go. This one's called 54. That's on channel 7 though. I don't have a channel 7. What about that one? Channel 4 and 5. What about that one? Channel 4 and 5. Can you move them? No, you can't, like, drag it up to another channel or something. Okay. What about, I'll just pick a random one down here. Nope. I'm going to have to create one, I suppose. So let's exit, because you can't go new. There's no new button. You can save and you can write it to the machine, but I don't want to do that in case it upsets something, because I don't have all those channels. And down here, there's your reluctor, so you're making your sine wave and so forth. Cool, eh? Let's exit that. We don't want to save that. Oh, let's exit. The file has been saved. No, I don't want to save it. So you click where you want it, and then left click, and then left click on it to delete it. Let's maybe just take those off in case it is saving it. Not that I'll probably ever use this one. Yeah, okay. Exit. Yes, exit. Once you choose your COM port, you have to go to serial port settings here and choose your COM port there that you've made it. So left button's okay. So that's how you do that. Signal editing again. All right, so let's go. We've got a channel 1 and 2. So let's go like this. And I don't know how many you have to do. If you're missing 2 teeth, is that missing 2 teeth? And then your next one, can you save that? So if we go save, give it a file name. So I'm going to go and make my own. So I'm going to want to go new folder, my waves. Yeah, that'll do. My waveforms, and we'll call it test. Save. Saved. Cool. Now you're supposed to write in, and that sends it to the machine. Yeah, hopefully that's doing that. Oh, fantastic. I don't know if the engine speed is only showing if it receives a injector pulse. It's entirely possible because it's not showing any engine speed at the moment. So let's hook up the oscilloscope. Let's get that on board and see what's doing. Oh, and there we go. I was a bit worried for a second there. I mean, I wasn't getting any signal out. And then I thought, what happens if I push the RPM engine speed adjustment knob, being a rotary encoder? And sure enough, it's a button that starts the signal. So if I push it again, it should stop. And it has stopped, but my scope has my scope's given up. Let's do this. There we go. There we go. So that's running again. Now if I push start, it starts quite low, and you got to wind it up. So there you go. Looks like it starts at quite a low speed, and you got to wind it up every time you start it. So maybe it's doing like 700 RPM, like in a typical idle. But anyway, there's the waveform we drew, a bunch of pulses, and then space of 2. Well, that's a good sign. So the software works. You can create a wave, you can write it in, and maybe let's have a look at the magneto one, eh? Why do we do that? So let's just knock that in the out of there. I cleared the wave, and I've drawn the reluctor waveform there. So we will move our scope probes over so we don't actually reference ground. We've actually got its own 2 outputs. And I will go right in. I don't know if you can write in while the thing's running, but I'll stop it just to be safe. We'll go right in, and it does the thing. And now if I hit run, I would hope to see something on my scope. Yeah, lovely jubbly. Very, very hard to trigger. What on earth? Probably because it's very intermittent. Let me just try something here. If I go 30 in the thing, phase 30, what does that actually do? I'll draw up to 30, and then we'll stop the engine. We'll go right in. Maybe it'll just, look, it writes a lot faster. It's not writing out that much stuff. Then I hit start engine. Oh, that's better. That's much better. It's not writing a bunch of blanks. Now, can I record this? Oh, there it goes. There it goes. So, scope software is not the best, but it is scrolling. You can see there's our reluctor waveform, and we have a gap where we put a gap. Hey, that's cool. It does seem to be doing the business there. Well guys, I hope you liked that initial look at the MST-9001A engine signal simulator. This is going to make for some interesting videos going forward, I think. But it's not as complex to use as you might think. They've put a lot of thought into it. I think at least the software could stand to be improved a little bit. But I think the hardware, the box itself, and the guts of it looks good to me. The third one from the right, the gauge there, it's actually saying 13.27, so it's on a really interesting refresh rate. If I get real close, does it show up? No, it doesn't show up. Yeah, so anyway, if you like that initial look at this box, please give me a thumbs up. Everyone knows thumbs up helps. And stick around, subscribe. You will see soon, I hope, all going well, a running ECU on this machine. I've got this one to check, and hopefully I can get the signals right to make that work. It's for a 3S GTE motor, Toyota. So thanks for watching. Stick around for more.